So, if you go here, you'll see there's a timetable. So by next week, you should take a couple of quizzes online in Canvas and start doing the first project. And the first project is ED30. And the way it works is you're going to need to have a Linux environment to do the work in this class. So you need to set up a Linux virtual machine. If you have Linux installed on a physical computer, you could use it, I guess, but that's not common. Most people use virtual machines because Linux is not really very good for ordinary use. So I use Mac for ordinary use, and when I want a virtual machine, I use it. Now, you can prepare a local virtual machine with Debian if your machine is reasonably powerful. If all you have is something really weak like a Chromebook or a tablet, then you won't be able to run a local virtual machine. And what you can do is you can use a cloud machine. And you should find those. I'll add those to this page, they're not here. But I have instructions to make a cloud machine in Azure and Google Cloud. And that's what you do if you don't have the ability to run a local virtual machine. I'll have those in there by next week. But anyway, local virtual machine, you have to install a hypervisor. And so here's the instructions for that. I recommend VMware. It's my favorite. Some people prefer VirtualBox. Both of these are programs that simulate hardware. So I use VMware. So I'll launch it here. On the Mac, it's VMware Fusion. VMware is free for both the PC and the Mac, but Broadcom bought it, and they have decided to punish you by making it extremely difficult to get the free version. You'll have to wander through a sort of maze on their website to do it. I've left instructions which help somewhat. Anyway, so here's Debian 12. And you can just download it and unzip it. Now, you can have various versions of a local Linux machine. In this case, I made a headless machine, which is what I prefer. This is what you get in the cloud with no graphics. Linux graphics are kind of useless anyway. If I want something graphical, I put it on the Mac. So a headless server is just available on the internet, and so I execute IPA to find the IP address, and then you connect to it with SSH. This is the easiest way. You can type in here and do work. It's just a miserable experience because this is the console. You can't scroll back, and you can't change the size of the font, and you can't copy and paste into it. So it's pretty irritating and limited. It's much better to connect by SSH, and that you do by using a terminal on a Mac or PowerShell on a PC. And now they have SSH included. So I can do SSH, the username is Debian, if you're using this machine that you downloaded, and all I need is that IP address, 192.168, 121, 190, okay? All right, and the password is also Debian unless you've changed it. Now I'm in. Now I have inside my Linux machine, I control it from here, and now I can copy and paste and scroll and everything. I still don't have any graphics, but I don't care. We're not doing anything with graphics in here. So I can now list files and so on. All right. So the first project is just to get it working. And here's some instructions how to set it up on various systems. By the way, I've got a Mac M1. So this is not an Intel processor. It's an ARM processor. And you can tell by doing uname -a. This shows you my Linux is running on ARM 64-bit. If you're on Windows, you'll be running on Intel, I believe. Now, unless you actually have an ARM-based Windows hardware, which some people told me existed, I've never seen one yet. Unless your machine is really brand new, you'll be running on Intel, which is fine. All right, anyway, you get a version of Linux going, and then there'll be a flag to turn in. So the flag is here. You execute this command. You copy the words behind the green banner. And now this will be the answer for ED 30.1. So to turn in your project, you go here and enter flags. If you're pre-registered, you should find the last 4 digits of your student ID here. If somehow you aren't, you can just register a new user here. And then you have to choose the right project, which is ED 30.1. So you put the flag in here and submit it. And when you do, you'll be on the scoreboard, which is here. So I did a test earlier today. Yeah.
So for the Linux machine, you go to the download link and then it pulls up a console, and then with that console there's an IP that you...
Yeah, IP space A.
Do you download that other SSH or whatever you called it? Do you download that as like a separate thing, or does it come...
Well, there's 2 things here, and this is good. Look, this here is the console. which, by the way, if it's real hardware, this will be a monitor in the server room showing this. And the only purpose of it is to see if the machine is up and you do things like restart it. You don't actually expect to do productive work on this because it's a real limited environment. This is an SSH shell. You're connecting into a running process on the machine, which is listening on port 22. And this is how you control cloud servers too. If you make Linux cloud servers, if you haven't done this, it's a good thing to get used to. And now you execute your commands here. This is how you remotely control Linux servers. And you can, yeah.
Our SSH is already a program on your computer that you can.
Yeah, Linux and the Mac already include SSH, and now the PC does too if you go to PowerShell. Now, if you have an old version of Windows, like Windows 7 or Windows 10 maybe, you might not have SSH and you might have to use PuTTY, which is a program you can download. And I can help people with that. That's what everybody used for years. Finally, Microsoft wised up about a couple of years ago and they finally put SSH in PowerShell. So you can just execute SSH right from the PowerShell command line. We've all been waiting for that for 30 years. But that's, anyway, this is good. Now you can control your machine from here. All right, and so that's the first thing to do by next week, get your Linux machine going. Now, if you don't know your Linux command line commands for Bash, then you might want to do this project, which is extra credit. And here, there's a page that just has a lot of lessons about Linux in categories. And each one of them has an answer, and this answer you can put here to see if it's right, and then to get points, you put it in my scoring system. Now, I think my scoring system doesn't have the LJ projects in it right now. I'll have to put them in. Let me check. Oh, it does. Good. All right. So in that case, the way it's numbered is these are 101 to 110, these are 201 to 219, and so on. That's why there's 83 of them. You can get 83 points extra credit. Each one is worth 1 point. If you want, this will teach you the basics of how Linux works. It's optional, but if you don't know Linux, I recommend it, and you can just submit flags here and get a whole bunch of extra credit points there. And then also, if this is easy, just skip ahead. You can do, all the projects are up, except for a few at the bottom I haven't written yet. You can zip ahead to whatever level is interesting to you. All my classes work like this capture the flag format because the students are diverse. Some people are brand new and only want to do the basics. Other people are experienced hobbyists or professionals and are bored by the basics. They want to zip ahead. If you want to zip ahead, go down here, do anything you like. This is C and debugging. Here's binary. Here's assembly language programming in x86. Here's some hacking exploits, where you take over machines exploiting vulnerabilities. Here's Windows exploits, where you hack into Windows at the binary level. And here's how you make other kinds of ARM systems. In particular, at some point, if you have a Mac M1 or M later, then you're running on ARM, and you won't be able to practice writing Intel assembly code on that, so you'll have to do this. You'll have to make an emulated system. And for that, you run this other product here called UTM. UTM is a front for QEMU. So if I run this one, this is an emulated processor. I'm actually running on an ARM64 processor, but this Debian is going to be on an emulated Intel platform. Now, in order to emulate a different processor, there's a lot of overhead. It slows it down by a lot. So if you run Windows in this environment, it is almost useless. You click and wait 30 seconds and click, it'll make you cry. But if you run a headless server, it's so efficient that it's usable, even with an emulated processor. So this is one way to get your hands on an Intel processor machine if you don't have Intel hardware. And as you see, it's taking a little while to boot up here. I'll let it go and see how it looks. Okay. And by the way, all right, so now I log in. And just like before, if I got the password right, which I guess I got it wrong, Oh, I changed it to something else and wrote it up there. Okay. All right. Now that I'm in, I do IPA like we did it before, just to get this address, which is 192.168.64.9. Now I can connect by SSH. So I can exit this one and connect to 192.168.64.8. But my username is now student on this machine. Did I get that right? Oh, 64.9, that's why, okay. Okay, 64.9. There we go. So now I'm on that machine, and if I do uname -A, it tells you I'm running on AMD 64, which is Intel 64-bit processor, which is emulated. So this program, UTM, is translating everything for every instruction, which of course slows everything down a lot, but it does work, and you can get work done here. And by the way, the other way, if you have an Intel-based machine, you can emulate ARM machines on the Intel processor the same way. All right. Anyway, so that's what I wanted to show you. Should be enough to get you started. Let me stop this recording.